Today we're going to study our last solid for the chapter. So far we've talked about prisms, cylinders, pyramids, and cones. We found lateral area, we found total surface area, and we also found the volume. So the last figure we're going to work with is not going to be a polyhedron. First thing, some review. Let's think back to the definition of a circle. So the definition of a circle is, suppose I give you a point and I tell you, you need to find, for me, all points exactly 2 inches away from this point. So you can go in all kinds of directions. You can go right, left, up, down, diagonal, whichever. Whenever you find all of those points that are exactly 2 inches away from that given point, I know this is a pretty poor picture, but you get the idea. You get this figure right here. Oh wow, that's terrible. So you get a circle. So the definition of a circle is the set of all points in a plane equidistant from a given point. We call that point the center, and then the distance to any point on that circle we call the radius. All right, so if we change one word in that definition, if we were to take out the word plane and replace it with space. So the set of all points equidistant from a given point in space. What kind of shape could that be? So starting from this point, I could not only just go all directions in this plane, I could come 2 inches off of the page. I could go 2 inches on the other side of the page. And if I look at the kind of shape that's formed, you get a ball. Oh my gosh, it's like our speaking bowl. So we call this thing a sphere. So a sphere is going to be the set of all points in space equidistant from a given point. So every sphere has a radius, just like a circle does. And we're going to measure spheres similar to how we measure circles. We really need to know that radius. Radius is really important. So a couple of different parts of a sphere. As I mentioned, every sphere has a radius. If you could imagine like the center inside of this tennis ball, somewhere in the middle, and I measure to an edge, maybe like this point, that would be my radius. Another part of a sphere that we're going to use a lot, if you notice I have this blue circle that kind of goes all the way around. Think of it like the equator on a globe. This is going to be something called a great circle. So I'm going to go ahead and write that down, great circle. So why is that so great? Big deal, huh? So a great circle, all that means is it has the same center and the same radius. As the sphere. So if we could locate the center of this ball, like if we could open it up and see the center, and if we were to find the radius of that thing, this blue circle is going to have the same exact radius and the same exact center of that. I could have drawn that circle going this direction, around this way. I could have drawn it diagonally. Just as long as I have the same center and the same radius, that's going to be something called a great circle. So we're going to come up with two formulas today. We're going to look at area and we're going to look at volume. Now, we looked at lateral area. We said lateral area was the area of all of your lateral faces. So if you have something like a prism, okay, this is like a rectangular prism. I know most of you don't know what this is. This is called a cassette. Well, this is the case to a cassette tape. Before we had CDs. I know, wow, I sound super old. So this is a rectangular prism. I could find the lateral area by finding the area of all those lateral faces. Okay, so that'd be my lateral area. Problem though with the sphere is you don't really have any lateral faces. In fact, you don't have any faces. So we're not going to have lateral area for a sphere. We're only going to have total surface area. So if they ever ask you a question, find the total surface area of, find the surface area of a sphere, it is implied that they're talking about the entire area. Okay, so what is the formula? How do you come up with it? The way you come up with it, there's a lot of different explanations. The real way that you prove it is pretty complicated, and it involves some math that we really just don't know yet. So this is going to be one of those days where I just give away the formula, and it's just going to be practicing how do I apply the formula. So total surface area for a sphere is going to be 4 pi r squared. Okay, so if you think about it, that's really just the area of a circle times 4. In fact, that's the area of any of your great circles, because they have the same radius and same center, multiplied by 4. I'll see if I can find some cool animations and post them on Schoology for you all to take a look at and maybe convince yourself why this is actually the right formula for surface area of a sphere. The other one we need is volume. Volume! Some of you might get that lame joke. So volume, I'm going to say V equals, now it's almost the same exact formula, so I'm going to copy that down, 4 pi and r, except I'm going to change a couple of things. Instead of r squared, we're looking at volume, so we're going to pump up the volume, going to make it r cubed, and we're also going to divide by 3. So this is your formula for volume. It's 4/3 pi r cubed. If you know the area formula, all you got to do is change that 2 to a 3 and divide by 3, and there you go. You have your volume formula. Okay, so let's practice some. Let's say that I have a sphere. Let's say this tennis ball has a radius, I don't know, that's probably of about an inch, maybe 2 inches, so 1.5 inches, go somewhere in the middle. If I wanted to find the area and the volume of this thing, let's suppose that the radius was about 1.5 inches. Then I'll say T for total area, that'd be 4 pi times 1.5 squared. Hit that in my calculator, round off, and then I would say inches squared. Because that is an area, we should have units squared. For my volume, I'm just going to do 4 pi divided by 3, and then 1.5 cubed. Plug that in your calculators, I know you can do that. And then you're going to get some value, and we want to make sure that we have inches cubed. So I'm going to stop this video right here, and then in the next one we're going to talk about hemispheres.